Okay, so today we're going to talk about randomness. Um, and randomness is used in proof-of-stake blockchains. Those are the ones where people put up coins and things of that nature in order to nominate the next node to validate the next block. So you remember, nodes get rewarded for validating blocks or for mining blocks. So the nodes want to get that block. Now, or get the opportunity to validate that block. Now, computers are deterministic. What that means is very simple. If you have the same code, you have the same inputs, and you have the same it'll always give you the same output. So, in other words, what that means is there's no such thing as true randomness in a computer like it would be rolling a dice, for example. So the question is, what do you do? How do you get a random number? Well, most programming language have some kind of random number generator in it. I don't think I've ever had to write one, but I've certainly had to use them. Now, all these random number generators, they usually allow you to give them pass some kind of seed value. That's the value that starts the cycle of pseudo-random numbers. And typically, if you're writing code that you want random, in air quotes, you might pass something like the current time, because every time you run it, the current time is going to be different. So you don't get the same results every time you run this code. I'm going to show you a quick example. Blockchains, from what I've seen, tend to be a bit more sophisticated, and that random number is usually combined with other factors like stake to create to select a validator, and it's kind of like a weighted game of chance or an election, where the more stake, more likely the random number is going to be in the range that makes you a validator. It's kind of similar, in some ways, to in Bitcoin, where you have the difficulty for miners. So if you make it more difficult, you lower the bar to numbers that will pass in terms of the correct answer. It's much harder to generate that number. The odds of you getting it are greater, so it's harder, and that's how they control the difficulty. Now, the blockchains such as Polkadot do not use simply putting a date in a random number generator. They use something that is a variable, they call a variable random function, or VRF, and it takes several inputs and produces not just a random output, but validation of that random number. And that's how that function works is a bigger discussion. They do have a discussion on that on the Polkadot wiki. There are other methods as well that are used, but anyway, that's one example of a sophisticated random number function that's used in blockchain. Now, so that you understand the concept, I created this simple Java program. I used the generator, they call the class entry point, doesn't really matter what it's called. And we used, I don't even think this one's not even needed. By the way, in Eclipse, if it's a yellow line here, it means it's not used within the code, so you can get rid of it. Anyway, so here's our main function, and I'm going to create two different random number objects. The first one here, I put in a fixed number, 10. Doesn't matter what it is, to prove the point. The other, I put in current time in milliseconds, which obviously changes every time you run it. And so I'm going to print fixed seed and date time seed. And you can see here, the fixed seed is 13, 80, 93, 90, 46. So you can see this pattern. And you know what? The date time seed, you get another series of numbers, 51, 74, because that's a different seed. Now, watch this. Right, you get the same pattern here, but notice this is different. 1380, and then goes through this whole thing down to 14. And if you run it again, you get the same for the fixed seed, same for the date time seed. So as you can see, this is a random number, but it's not really random, because once you run it, once you know with the same seed, you're going to get the same result. This 100, by the way, so what's going on here is here I set up my object. Think of this random number box, black box, and I set up another one, and I give it, as I said, the seed value. Now what I'm doing for the first 10, well, for both of them, is I'm printing out the next random number. I am having the number go 0 to 100. And that's all I'm doing. But you can see the difference here, because this value is always going to be different, this current time in milliseconds. The results here are always going to be different. So why would you even want to bother with a fixed seed? Well, let's say you're testing. You want to know that if you want to test to see if something's correct, that involves a random number, you want to make sure that your input from, or your random number that you're using in this test, is the same pattern every time, so you can see that your results are an expected result, especially if you're writing formal test code. In Java, it's called JUnit. There are other ways in different languages, but if you're writing something in JUnit, you'll often have code that says assert that this value coming out of this method is X. Well, if that method is using a random seed, then, or a variable seed, you have nothing to balance it against, right? So you don't know what that value should be that you're comparing your result to, because every time it's different. So that's when you would use a fixed seed. Normally, if I need a quote random number in a program, I'll do something like this. This is usually sufficient for most business type programs. But again, I mentioned in the blockchain, they get a little bit more sophisticated, and I think it's sometime I'd like to go through that at a later date. Anyway, if you found this useful, please give a like. If you want to see more, please subscribe and hit the bell to get notified, and I will speak to you next time.